So recently I've had some time to look at external drivers with OnStep. And what I have here are two external drivers, CL57Ts, and connected to those are a NEMA 23 and a NEMA 24. Both of them do have encoders on them. The encoders are wired up and the motors are wired up, and then I'm supplying both external drivers with 24 volts DC, so they've got their own power supply. And then these are just my oscilloscope test probes. I'm reading the pulse signals on each one so that we can see, have a little visual of what's going on here. This is the Max ESP4. And then on the Axis 1 and Axis 2 slots are shift sticks. This is all this is designed by Howard. These shift sticks are kind of a key to getting external stepper drivers working reliably. These are 5 volt logic level. So the signal coming in, these are expecting 5. There's a little switch on here, 524. You want to make sure it's on 5 volt. So each one's set to 5 volt. And then the problem is ESPs and TCs are 3.3 logic level. So the voltage coming out of here is not quite sufficient to drive these. Now, maybe, I have, small wire runs. I have gotten it to work, but I wouldn't count on it to be reliable. You're going to want to supply a 5 volt signal, and that's what the shift stick does. Now, from my understanding, there's this chip on here. It's a transceiver, let's see, it's a 74 HCT 24.5 octal bus transceiver. Its job is to logic level shift. So it's going to shift that 3.3 up to a 5 volt signal that the external drivers are expecting. The way it's built right now is you have an option on how this needs some power in order to make it run. You can take, say, the 5 volts from your board. Currently I have this plugged in on the 5 volt of the ST4 port. I'm just bringing 5 volts over and plug it into this Axis 1 shift stick. So that 5 volts what's powering this top one. Or you can add these components on the bottom. At the time I had these produced, the PCB manufacturer wasn't doing two-sided SMT work, so I have had to place these 3 components onto the bottom of the board. Now what this is a 5 volt linear regulator and 2 capacitors. So what this is doing is actually taking in, see, I've got 12 volts coming in. It's taking the 12 volts on VMOT and it is converting it to 5 volts. So this particular one and the one on Axis 2, it doesn't need this external power 5 volts. It's making its own. It's taking the voltage that's being supplied on the PCB, and it's doing a conversion to 5 volts with these components on the back. So I have 2 examples of these shift sticks running in 2 different ways. The one reason you would want to not use the 5 volts is this linear regulator is only good to, I think, 15 volts. So if you're running 24 in here, you're going to want to use a different 5-volt source than what these can provide. So keep that in mind. If you want to be running your, the whole PCB on 24, not sure why. Maybe, maybe these two drivers you want 24. Your focuser, but anyways, so if all you're doing is providing enough voltage on this PCB to run external, then run 12 volts. And then you'd be able to use these components on the bottom to simplify your wiring and not have to have this 5-volt connection from the PCB over to the shift stick. We'll go ahead and we'll enable tracking. And you can see, let's see, blue is right ascension. So we're actually reading the signal of right ascension now that tracking is enabled. And then if we run declination, you can see we've got a signal on declination. So we've got our two signals. Now, another example that I can show here is if I unplug our 5-volt source, you can see our signal is down to that 3.3 volt signal. Yes, this is still running. Is it running reliably? And, that's to be seen. Also, our cables are relatively short. Bringing in the 5-volt onto the shift stick, you can see it brings the signal up to the 5-volt. That's kind of an overview of how all of this works together. The actual wiring, I'll have a diagram of, and I also have all of my code that I have on these ESP32s and H266. They're on my GitHub page. But I wanted to briefly show, external stepper drivers working with OnStep. We'll go ahead and do a go to a star. We can watch motors run. So you can see our signal up here on the oscilloscope, and we can see the motors running. So again, I'm bringing in what these wires are coming out of these slots now. What the shift stick is providing is the pulse, the direction or dir, and the enable, and a ground. So what you do, and again, I'll have a diagram for wiring, is the ground you share across all three. You'll have it on pulse negative, dir negative, and enable negative. So one ground to all the negatives. And then the positives, you can see what we got here is the top pin is ground, black is enable, next pin down is yellow, and that is pulses, and then white is direction, DIR. Again, reference the diagram that I have for official wiring, so it's better than looking at this mess of wires. So that's it in a quick kind of little synopsis. I'm trying to think of anything else that I want to mention. So that's an overview of what I've learned about running external drivers with an OnStep PCB. The main thing is taking your 3.3 logic level signals and bringing them up to 5-volt. And that's what Howard's shift stick does. And it does it quite well. You have a couple options as far as powering the shift stick. One is, is an external source, or there are 3 components you can add to the back of the PCB